everybody, welcome back to Viral Integrals. So today we are solving a classic integral where the denominator looks like the hard part. The trick is to add a parameter so that when we differentiate, the log cancels out. The trouble is at x equals 1, the numerator and denominator both go to 0. That looks like a problem at first, but it has a removable limit, so this is not actually going to be a problem. The numerator x minus 1 is the version we want at the end. To make progress, replace x by x to the a. When a is 1, that brings us back to the original numerator. We're going to define a function of a, big F of a, with that flexible numerator. This makes the original integral equal to big F of 1. So if we can find big F of a explicitly, we can finish the problem by plugging in a is equal to 1. Also, let's check an easy value right away. When a is 0, x to the a is 1, so the numerator becomes 0. That gives f of 0 equals 0. We need big F prime before we know f. This is where the Leibniz rule for differentiation under the integral sign helps. It lets us differentiate the a inside the integrand. Video 2 derived this rule, and it will be linked to in the description. Only x to the a changes with respect to a. Its derivative is x to the a times log x, and that log x cancels the denominator. Now big F prime is just a power integral. For the a values we need, that evaluates to 1 over a plus 1. Now integrate f prime with respect to a. The antiderivative of 1 over a plus 1 is log of a plus 1, plus a constant. Use the easy value from earlier. The integral version gave f of 0 equals 0. Plugging a equals 0 into the formula gives the constant, so c equals 0. Now the whole parameter function is known. Big F of a is log of a plus 1. This is why we introduced the parameter. And finally, plug in a equals 1, because that is the value that turns x to the a minus 1 back into x minus 1. And that's it. So the original integral equals log 2. The reason this method worked is that differentiating with respect to the parameter created the exact log factor we needed to cancel. All right, guys, I hope you enjoyed that, and we will see you next time.